Hi everyone, this is Ms. Brubeck. We're going to go for a couple definitions here. So the learning target today is I can graph quadratic functions by finding the vertex and by finding two other coordinate points. So the equation for a quadratic is y equals ax squared plus bx plus c. We were talking about that in our previous slides when we learned how to factor. A parabola, that's the shape that a quadratic makes. It's called a parabola and it looks like a U. Then we have vertex. That's the maximum or minimum point of a parabola. Zeros are the x-intercepts of a quadratic or a parabola. And then line of symmetry. Every parabola has a line of symmetry in which the figure can be folded in half so that each half is identical to the other half. It's like a mirror image. And then concave up and concave down. The left, that's concave up, where the vertex is the lowest point on the y-axis. And then concave down is right here on the right, where the where the vertex is the highest point on the y-axis. So this slide wants us to find the vertex, the zeros, and the line of symmetry. Our vertex is going to be our lowest or highest point. So our vertex is right here. That's our vertex. The zeros are where the graph hits the x-axis. So our zeros are going to be right here. That's our zeros because that's where the graph hits the x-axis. And then our line of symmetry, it goes right through our vertex and it cuts our graph in half. So our line of symmetry is going to be right here because, or our axis, you can call it a line of symmetry or an axis of symmetry. It's right here because it cuts the graph in half. Now this graph doesn't have arrows, but it should because every quadratic is going to keep going on forever unless they tell you restrictions. And then the bottom it asks, is this parabola concave up or concave down? And it is concave up. Oops. Sorry about that. All right, slide 3. Now, we are given this quadratic right here, and it's important to know that we have an A, B, and C. So the 2 is our A. Well, that doesn't look like an A. The 2 is our A, the -4 is our B, and the -5 is our C. And to find the vertex, there's an equation we can use, and it's called x equals negative, me and this Jamboard, negative b all over 2a. And that's always going to work to find the vertex. That is a formula that was made up by mathematicians a lot smarter than me. So we're going to have negative, and then we need to put in the -4. So the -4, that's our b value. That's going to go right in here. And then we're going to have our 2. It's going to be here. And we want to multiply that with our a, which is 2. So if we simplify that on the top, 2 negatives, that's going to be a +4. And on the bottom, 2 times 2 is 4. So that's going to be 1. So it's going to be x equals 1. And so then what we can do is we can plug that into our original quadratic. We can have 2, but instead of an x, we're going to put a 1. And then instead of an x after the 4, we're going to put a 1. And so what that's going to get us is we want to make sure we do the exponent first. You always do exponents first because remember, PEMDAS says exponents before multiplication. So 2 to the first power is just going to be 1. Oops. Then we can go ahead and multiply. -4 times 1 is just going to be -4. Bring down our -5. We know that 2 times 1 is just 2 minus our 4 minus our 5. And then simplify. 2 minus 4 is -2 minus 5 is going to get us a -7. So what we have now is a coordinate point. We can say x comma y, and that's going to get us a coordinate point of 1 comma -7. We can go ahead and graph that. So our vertex is going to be 1, -7. Now we need to find 2 other points by making a table of values. And we can do that by finding 2 x values. Now, because everything's going to be the same on the right and the left side, I'm going to take this number. this 1. And we can either add 1 to it, or we can add 2 or 3. I'm going to say let's go 2 values to the right and 2 values to the left. Okay, let's go 2 values to the right, 2 values to the left. So if I do 1 plus 2, I'm going to get 3. And then if I do 1 minus 2, I'm going to get negative 1. So I'm going to plug those numbers into the quadratic. So we have 2, but instead of an x squared, I'm going to put a 3. And let's see, it's minus 4. Okay, so minus 4. Instead of an x, I'm going to put a 3 and then minus 5. And I get a positive 1. And I'm going to do the same thing, but I'm going to do it with a negative 1. So negative 1. Oops. And you should get the same number. We get 1 for both, and that's the way it should be. We should get a 1. And I'll show you why when we're graphing that. It's going to be 3, 1, and then negative 1, 1. See how it should be the same on both sides? It should be a mirror image. So it should be a mirror image on both sides of the parabola. Now, it's really hard to make straight a parabola on the Jamboard, but that's going to be the best I can do. And if we were to have an axis of symmetry, it should look about the same on both sides, right? Moving on to the next one. This time we have a negative in front, but we're still going to be using our negative x equals negative b all over 2a. Now that negative in front is going to mean that our graph is going to be concave down. Okay, that negative in front is going to mean our graph is going to be concave down. A is going to be negative 1, B is going to be 4, and C is going to be negative 1. So when we plug that in, we're going to have negative, and then we'll put our 4 in, and then we'll have 2, and then the A is negative 1. So that will simplify to negative 4 all over a negative 2, which will simplify to x equals negative 4 divided by negative 2 is a positive 2. We'll then plug that in. We're going to have negative, and then our x is going to be 2, and we'll square it, plus 4, but instead of an x, we're going to put in a 2, and then minus 1. Then what we need to do is we need to do the square before we add our negative. So we need to do 2 squared first. So we're going to have 2 squared first, which is negative, or which is, sorry, 2 squared is just 4, and then add your negative. Then we'll have 4 times 2, which is 8, and minus 1. And then we'll have negative 4 plus 8, that's going to be 4, minus 1, which is 3. So our vertex is going to be 2, 3. That is our vertex, and I'm going to go ahead and graph it. 2, 3 is going to be right here. Let me just make sure I did that right. Yep. Oh, no, I did not do it right. No, I did. Negative 4 plus 8 is 4. Negative 4 plus 8 is 4 minus 1. Okay, we're good. Sorry, I just want to make sure I didn't make any mistakes because I've made mistakes in the past. Then we're going to have our x and our y. And again, I'm going to take this value here and I'm going to just add 2. I'm going to do 2 away. So if I do 2 plus 2, I'm going to get 4. And if I do 2 minus 2, I'm going to have 0. And so I'm going to plug that into here. I need to get rid of these guys. And I'm going to have a negative. See, we're doing 4 squared. So an x. And then plus 4. And then plug in a 4 in for the x. And minus 1. And I got a negative 1. Okay, and I should get the same thing when I plug in a 0. I should get the same thing when I plug in a 0. And I get another negative 1. So I'm going to have negative 1 and negative 1. And I'm going to zoom in to make that point. And so we're going to have 4, 0 right here, and no, sorry, that's wrong. 4, negative 1. We're going to have the point 4, negative 1, which is right here. And then we're going to have the point 0, -1, which is right here. And as you see, it's going to be about the same. I don't really like how that I don't really love how that vertex came out, so I'm going to try it again. It's going to be 2, 3. There we go. And so when we make our parabola, it should look about like this. It should look, if it was done professionally, it would look the same on both sides, but it's hard to do it on the Jamboard. One more example. We're going to do the same thing as we did before. We're going to have x equals -b all over 2a. And our a is going to be, there's an a, there's a 1 in front of that x, so that's our a. Here's our b, and here's our c. So we're going to have a negative, and then our b is a -4. Then we're going to have 2, and our times 1, because our a is a 1. So that's going to be +4 all over 2, which is going to equal 2. So our x equals 2. Then if we plug that in, we're going to have 2 for our x, and we'll have to square that, and then -4 times 2, and then a -5. So 2 squared is going to be 4. -4, let's see, -4 times 2 is going to be -8, and -5. So 4 minus 8, that's going to be -4. And then -4 minus 5 is going to be -9. Oh, did I do that right? Let me check that. -5. 4 minus 8 is -4, minus 5, -9. Good. So our vertex is going to be 2, -9. I can go ahead and graph that. 2, -9 is going to be right here. I can do that better. And then this one, this has factor. So try this by factoring. And this we can do by factoring, because we need to find two numbers that multiply to get you -5 and add to be -4. So sometimes you can do this by factoring. That's going to mean we can use the factors of what two numbers multiply to get us -5 and add to be -4. Well, it's going to be -5 and -1. Because if we add those together, we're going to get -5 times I don't mean a -1, I mean a +1. -5 times a 1 gets us -5, and -5 plus 1 adds to be -4. So if we set those equal to 0, what we're going to have here is we're going to have x minus 5 equals 0, and we're also going to have x plus 1 equals 0. So we can add the 5 to both sides. And if we do that, the 5s would cross out, and we'd be left with x equals a +5. And then we can do the same thing over here with the 1s. It's a +1, so we can subtract the 1 from both sides. When we do that, the 1s will cross out, and we'll be left with x equals -1. And those are our zeros. These are our zeros, or our y-intercepts. So we can plot those then. We can go to our x-axis and plot 5, and x-axis and plot -1. Yep, and that should work. Oops. Well, I'm struggling to make my parabola, but I think you get the idea. And that's it. Yep, that's it. Thanks for watching. And if you make sure you get this written down.